Good morning or afternoon, everybody. I hope that you have had a great weekend and that you are refreshed and ready to start a new week with our class. I hope everyone is staying safe and making good life decisions and good choices. Okay. Whether you realize it or not, we are starting our last chapter, which is chapter 5. But the other thing I want you to realize is we only have 4 more lessons of instruction. So we've got 4 more sections, and then we will have a test review, then we will have our chapter 5 test, and then we will be at the end of our course. Well, we will just be reviewing for our final exam and then actually taking our final exam. If you haven't looked at our tentative course schedule, that Google sheet that you've had access to all semester long, I would strongly advise that you access that and take a look at it so that you've got a good outline of everything that's left for this semester. I'm also putting details of what we are doing each class day on that calendar, just like I would any other time. So when we have a Zoom session, I put it on that calendar. When you have a test, like always, I put it on there, and I even have changed it to say your test is online via Wolfden. So please, if you haven't had a chance to check that out, you'll also be reminded of each of your homework assignments. Without further ado, we are going to go ahead and get started. We are going to be looking at Chapter 5, Section 1 today, but I've added some extra material into this chapter from another section just to kind of categorize some things together. So everything that we're doing today is going to be revolving around graphing. So the second half of this class, we will be graphing something called logarithmic functions. That is actually found in a later section, but I wanted to try to do all of the graphing in one day because they build on top of each other. And you'll see that in just a few moments. But anyways, just letting you know, we're going to be graphing all day today, so you're going to want some graph paper. You might want a ruler if you don't have graph paper so that you can draw your X and Y axis. You may want some colored pencils or some highlighters, some different things like that. Whatever you need, pause the video, go grab that, and then we start back with us. We've got 3 overarching learning targets today. But again, keep in mind we're also doing the logarithmic functions as well. So I can graph exponential and logarithmic functions without a calculator. Emphasis on that. We will be doing all of this without a calculator, which means I can't keep you from using it because this is virtual, but what I can do is require you to show the work. And if you can't show me the work, then you don't get credit. A lot of you had issues with that on your test. I'm not sure why, because every single test that we have taken this year, I've said you can use calculator if you want, but you have to show me the work algebraically regardless. And if you can't, then you don't get credit. That's no different on our virtual tests as well. That's no different when we are going to be graphing these exponential and logarithmic functions. We'll be using some key graphing components. So there's going to be a lot of rules, a lot of things to study and memorize in this chapter. So out of all the chapters that we have covered this semester, this is the one that has the most required for you to study, which is a big deal because a lot of you do not study. You're going to have to be successful on this test. So just get your head in the game for that one because it is only going to add and add more and more rules for this chapter. Our second learning target, I can recall those transformation rules of functions and apply them. X minus h, that transformation rule, and if there's a plus k term, what that transformation rule, the vertical stretches and the vertical reflections, different relationships like that. You're definitely going to have to recall those. I'm not going to reteach those. I'm going to put them up on the screen, and you can pause the video to write them down if you want, but I'm really just going to point out how they show up in an exponential format or a logarithmic format. Our last learning target will be revolving around our actual graph. So once we have finished those first two learning targets or completed those for a problem, then we're going to have to answer some questions about our actual graphs. So this is going to be really important. You can't get this learning target down without getting the top two first. AKA, you can't get questions right from this third learning target without getting the top two learning target content right. So it's going to be important that we understand how to graph, and then how do we read our graphs. If we can't graph, then there's no way that we can pick information off of that graph, because we'll be pulling incorrect information. So just keep that in mind. We really got to nail down graphing today. Okay. So to kick us off, we're going to look at the most basic exponential function. I'm not going to add a bunch of stuff to it right now. I just want us to break down its most basic format. So an exponential function obviously involves an exponent, but that exponent deals with the variable. That's a little different than what we are used to. We're used to having 3x squared, where the variable is being raised to a power. With an exponential function, it's a number being raised to a variable power. It's backwards. That is kind of the big difference between what we have been doing and what we are starting out today. I want to draw your attention over here to this standard format of an exponential function. We're going to add some to that shortly, but this is just the most standard basic format. So f of x, or y, equals b to the x power. So obviously x represents power. B is going to represent something called the base. So that's your first big term that you need to learn today. Whatever is being raised to the power is what we are going to refer to as its base. Now, some things you need to know about your base. Your base is always going to be greater than 0, and it will never equal 0, which makes sense. If it's greater than 0, it can't equal 0. And so when we're starting out with something new, and especially when we can't use a calculator, the question always arises, how in the world do we get started? Like if I wanted to graph f of x equals b to the x power, how in the world would I graph that? And so here is the second thing that you really, really have to study. This is what I kind of refer to as your big three, meaning your big 3 points. When we first started out learning how to graph something, we learned either find the y-intercept and the slope, or plug in x values and get y values, and you've got points that you can plot. Well, with an exponential function, I'm trying to save you some time. Instead of you just picking random x values, I'm telling you which x values to start out with. And then I'm also even telling you what the y values will be, but you have to learn these big 3 points. If you do not learn those big 3 points, then you are not sitting pretty for this chapter. You've got to know this. Okay? So here are those big 3 points. No matter what your exponential function is, you can always start out with these 3 main big 3 points, and then we can adapt them based on any transformations that we might encounter. Those big 3 points are an x value of 0, a y value of 1. Okay, so we might, or what you would do is if I asked you to graph this function, you would create a table of values, and immediately you would say, I've got an x value of 0 and a y value of 1. I've got another x value of 1 and a y value, or an f of x value, of b. Well, remember that b represents the base. Okay? So whatever the base is of my function, I would replace that for b. Okay? And then my third big point is negative 1, comma, 1 over that base value. Okay? So if I was trying to graph the function f of x equals 2 to the x power, my big 3 points would be 0, 1, 1, comma, 2. Okay, let me write that out for you. If this is what I was trying to graph, my base would be 2. So then my points would be 0, 1, 1, comma, the base, which is 2, and then negative 1, comma, 1 over the base, which is 1/2. Another key or important piece of information that you need to make sure that you learn today, that you write down in your notes, is that for every exponential function, you're going to start out with a horizontal asymptote, horizontal asymptote at y equals 0. Remember, asymptotes are lines, so you need to write them as equations. So every horizontal asymptote is going to start out as y equals 0. Okay? And then the only way that will change is if we have a vertical shift up or down. Okay? One other piece of information that you'll need to know is, what if I ask you to identify where the graph is increasing, or is it decreasing? Is it constant? Questions that you have already seen in previous chapters. Okay? Well, with an exponential graph, when your base number is greater than 1, then that means your graph is going to be increasing the entire time. It will never change from increasing. It will always be increasing. This is what we call an exponential growth model, or an exponential growth graph. The reverse of that, if your base is somewhere in between 0 and 1, so it's some kind of fraction or decimal less than 1, then your graph is going to be constantly decreasing the entire time, and this is what we would call an exponential decay model, or an exponential decay graph. Again, there's not really any math calculations involved there, but I may ask you to say, or tell me, is this graph an exponential growth or exponential decay model? And you would just need to pick one over the other. Now, this is a very full slide of notes. There is a lot of words happening on here. However, every single thing on this slide, with the exception of the actual equation or the actual standard function, everything else on this slide is old. It is something that you should have learned in chapter 2. Okay? And these are those transformation rules that I was talking about. So when we looked at quadratics and we were graphing from x squared to x plus 2 squared, that's a horizontal shift because you have an h term involved, or x squared transformed to x squared plus 3. That is a vertical shift up 3 because of its k term. That exact same rule, or all of those exact same rules, are going to apply with exponential functions. And in fact, they're going to apply to the logarithmic functions on the back half of this lesson as well. And so just like before, if there is an a term, like if there's a negative sitting out front, or if it's 2 times x squared, then that is a vertical stretch. Okay? And so that will either stretch out our graph and make it increase a lot faster or decrease a lot faster, or it can affect it by flipping it vertically. Okay? And you'll see that here written down as well. All the other things are also just some of those old transformation rules, h and k, even the c, which we didn't spend a lot of time on in previous chapters. We also won't spend a good bit of time on it in this chapter as well, because you just don't see it very often. There are other important things that we need to focus on. But you still need to know all 4 of these rules. You should already know all 4 of these rules. Pause this video, jot these down so that you have them in your notes, and that you know, hey, all those transformation rules that I learned a month or 2 ago, they're going to apply for exponentials as well. They're even going to apply for logarithmic functions that we're going to graph too. So pause this video, get these written down, and we will reconvene with some examples. Okay. A couple more things to add into our notes before we actually start graphing. Everybody remember pi? 3.14, dot, 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 dot. It's a never-ending number. It's an irrational number. Well, there are some other irrational numbers out there as well. One of those being the letter E. Now, E is an irrational number that is about 2.71, 82, 81, 8, dot, 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 dot. We usually just refer to it as, depending on what your professor prefers or what your directions say, you're either looking at this number rounded to the nearest thousandth or to the nearest tenth. For our class, because of what we're going to be doing and because technically I'm saying no calculator, I'm going to say treat E as 2.7. Okay? Everybody needs to write that down. Treat E as, and I'm using the approximate sign, 2.7. If you do not use 2.7, then your answer will be wrong. It will not match mine, which means I'm counting it wrong. Okay? So for our purposes, we all need to be rounding in the same manner. So we are going to be rounding to the nearest tenth. If you don't round to the nearest tenth, you will be wrong. So please make sure you write that in your notes. No excuses, just do it. And if you don't do it, it's going to be counted wrong and we're not going to argue about it. I'm tired of arguing with some of you. Just follow the directions. Okay. So we're going to treat E, it's a never-ending irrational number, but we're going to treat it as approximately 2.7. Now, why do we need to know that? Well, E can serve in an exponential function as well. E could actually be the base of your exponential function. So instead of 2 to the x power, we could have E to the x power. And there's nothing wrong with that. E is a number after all, which means we can raise it to that variable power. And it's the same exact process. So those big 3 points, I want you to pause this video. I want you to write those big 3 points. See if you can remember them, because you're going to be writing them a lot today. So pause this video, write those big 3 coordinate points out. These are those big 3 points: 0, 1, 1, your base, and then -1, 1 over your base. Well, if we were trying to graph or identify the big 3 points for this function, f of x equals e to the x, what is your base? Well, your base is e. Okay, so then let's fill that in. Let's adapt those big 3 points. 0, 1 is going to stay the same. 1, b, your base is e. Okay. Now, if you're going to graph that, you need to have a numerical value. And remember, we're treating that as 2.7. Okay, so right there, there's a coordinate point of 1, 2.7. Okay, and then your third one, -1, 1 over b. Well, 1 over b, 1 over your base, that would be 1 over, or 1 divided by e, or 1 divided by 2.7. Okay, now, since you aren't technically supposed to use your calculators, I'm going to tell you what that is, and you need to use that number. You are going to have to memorize that number. It's not going to be given to you. You're not going to have it on a cheat sheet unless you are cheating. Okay? You are going to have to remember that. 1 divided by 2.7 is going to be rounded to the nearest tenth, 0.4. So there are your big 3 coordinate points. Okay? 0, 1, 1, 2.7, and -1, 0.4. Okay? So I'm going to try and graph these on this coordinate plane that's given to me and see if it matches up with what's already there. Okay? So 0, 1. 0, 1 is right here. Okay. Check. +1, 2.7. +1, 2.7 is going to be right up in this area, more than halfway, so right around in here, which is exactly where my graph is. Check. And then -1, 0.4. So go out to -1 and almost halfway, but not quite. There it is. And if I connect those points, I've got the exact same graph that I provided for you at the very beginning. of this slide. And so those big 3 points, hopefully you can see they're going to be super useful. They're going to be very important. If you don't learn them, you will not be successful. I'm not going to take any 3 random points. I want those 3 points demonstrated in your notes, in your homework, and on your test. I don't want any others other than those big 3 points. And so today's practice in class will be all about implementing those big 3 points. The other thing I want to remind you of is, remember, for an exponential function, unless there is some type of vertical shift, your horizontal asymptote is y equals 0, which is right there. Okay. Okay. And look at where your graph in green or in orange, whichever one you're looking at, look at what it is approaching. It is approaching that asymptote, but it never crosses it. Okay? Hence the purpose and the definition of an asymptote. So those are your big pieces of information so far. All those transformation rules, knowing what your base is, the big 3 points and how to use them, and your asymptote. Okay. Now the last little bit of information that I need to introduce to you as far as new content, and then we'll practice it all, is this idea of in behavior. Okay? So far we have talked about in behavior as what is the left hand of the graph doing and what is the right hand of the graph doing. Okay? What's the left hand behavior? What's the right hand behavior? Okay? And there's nothing wrong with that. However, there are multiple ways to write that or to notate that. And one of the ways that you can do that is using limits. Limits are going to tell us the exact same thing as in behavior. It's just written in a different format. I want to draw your attention to this statement right here. And I just want to read it to you so that you can see the visual and hear the words of how to read it before we talk about what it means. So this statement is read, the limit as x approaches negative infinity of my function. I will say that again. The limit as x approaches negative infinity of my function f of x. That is how this statement is read. So now that we know how it is read, the question becomes, what does it actually mean? So I want you to take a look at the graph. This is the same graph from the previous slide, but we can look at any graph and identify or find its limits, if you will. But we're just using this graph because we just graphed it ourselves. We just looked at it. So it's familiar to us. The limit, okay? The limit as x approaches negative infinity. Okay, let's pause and let's stop right there. Not the video, but let's just pause our reading. Okay? When our x values are approaching negative infinity. So if I start at the origin and I start working my way towards x values, if I start at the origin and I start drawing like a little dotted line of my x values that are approaching negative infinity, what is my graph's y values or its f of x values approaching? Okay. So as the x values approach negative infinity, what are the y values approaching? Okay. They are approaching 0. Remember, we're thinking y values. As the x values are approaching negative infinity, the y values in this graph are getting really close to 0. Now, they're never going to actually get to 0 because there's a horizontal asymptote there, but they are approaching it. The limit as x approaches negative infinity of my function equals 0. AKA, when the x values are going towards negative infinity, what are the y values going towards? They're getting close to 0 in this case. Okay. So that second part, down here at the bottom, I will read this one to you. This one is red, the limit as x approaches positive infinity of my function. Okay? So same concept, but this time, as my x values are approaching positive infinity, so I'm going forever and ever to the right, what are my y values approaching? What are the y values of that graph approaching? Okay. Now remember, there's an arrow here. There's an arrow here. My graph hasn't stopped. There's no defined point there. We just ran out of graph paper. So what is the graph approaching? It's keeping it going forever and ever. So its limit as x approaches positive infinity is positive infinity. Now, just like with everything else, the limits are going to be constantly changing based on what our function is. This function is f of x equals e to the x. If our function was f of x equals 12 to the x power, then our end behavior may be a little different. We don't know. It's all dependent on the graph. And that takes us back to that third learning target. I can identify key information about my functions using my graph. And so this information is some of the stuff that we're going to pull from our graph once we have it graphed. All right, so that brings us to our first example that we are going to tackle when graphing exponential functions. Our first example that we are asked to graph is f of x equals 3 to the x power. Before we go any further, I want you to pause this video and I want you to jot down that function. I want you to go ahead and write down domain blank, range blank, the two limits and leave a blank, and the asymptote and leave it blank. Go ahead and draw yourself an x and y axis, or use your graph paper to draw your x and y axis. Okay, but go ahead and pause the video and get that information down. That way you're not having to try and write all that down as I'm talking through how to graph this problem. So pause the video, jot down the problem, and then press play to keep going. Okay. One of the first things we learned about how to graph anything is, when in doubt, plug in some coordinate points or plug in some x values and get some y values. When we're graphing exponential functions, we don't have to start from scratch. We have those big 3 coordinate points that I've given you in your notes that you've got to memorize so that you can use them on your test. Okay? So pause this video and off to the side draw yourself a table of values and write in what you think those big 3 points are based on this function. Before you go any further with that, I want to help you out. Okay? To get those big 3 points, you have to know what the base is. So for f of x equals 3 to the x power, what is your base? Your base is 3. Okay? So pause this video and try to fill in your big 3 points. Okay? So there are your big 3 points, 0, 1, 1, your base, which is 3, so 1, 3, and negative 1, 1 over the base, or negative 1, 1/3. Now the other thing that we have to address is, remember all those transformation rules with h's and k's and a's and c's. What I want you to now take a moment to do is identify any of those. In this function, is there an a that is written? Is there a c term that's written for us? Is there an h term or a k term? Okay. There is no a. Okay. It is, but it's 1. It's not written, and 1 is not going to transform our graph. It's going to remain the same. Same thing with c. c is 1. It's not written. It's understood to be to the 1x power. It's not going to change our graph, so no, we don't have a transformation there. There's no provided h term, and there's no provided k term. And so this is a very basic problem starting out because there are no transformations happening. You can think of this as a type of parent function because it's in its most basic form. Okay, so you've got 3 points. That's all you need. You need those 3 points, not random ones that you trace off of your calculator. I want those 3 and only those 3. Okay, and so now graph them. I got a point at 0, 1. I got a point at 1, 3. And I have a point at negative 1, 1/3. And again, that's an estimate there. It's not perfect, it's not exact because it's a fraction, but it's in the right zone. Okay, and even with just those 3 points, I can see the shape that my graph is taking, the curve, if you will. Okay. And so just to bring in one of those, some of those terms from earlier, is this an exponential growth or an exponential decay? Is it constantly increasing or growing, or is it constantly decreasing or decaying? It is a growth. Because as I read from left to right, my graph is increasing. Okay. Pause this video, see if you can fill in the domain and range, because that is old school. You definitely should know that. You should also be able to tell me what the asymptote is based on your notes from earlier. Okay. So your domain is all real numbers, parentheses, negative infinity to positive infinity. Your range is from 0 to infinity, but be careful, your range is parentheses 0, not a bracket. That is because your graph is approaching 0. Think about those limits. It's approaching 0, but it never actually gets there. It never actually touches it. So it's not going to include that value, hence the parentheses. Okay. Speaking of limits, okay, the end behavior. As my x values approach negative infinity, what are the y values approaching, or what is the f of x value approaching? 0. And the limit as x approaches positive infinity, so as my x values move to the right, what are the y values doing? They are approaching positive infinity as well. Okay? And that's it. You just graphed your first function. Okay. If you have any questions, write those down, email them to me, send them to me in a remind, or hold them until we have our next Zoom review session. And let's get those questions out of the way because we're only going to be adding more and more content. It's a pretty advanced chapter, so write those questions down, email them to me, or send them to me in a remind with the actual problem included. Here is your second example. We've got f of x equals 4 to the negative x power. Before you start doing anything else, I would suggest getting into the habit of writing out all the information that you know from this function. Okay, so first thing, do you know what the base is? For this function, the base is 4. Okay. The next thing we want to ask ourselves are those transformation rules. Is there an A? Is there a C? Is there an H term? Is there a K term? Okay. Right. An A term would be sitting in front of the 4, so it would be like a negative times 4 or a 2 times a 4. We don't have either of those situations, so there is no A term. However, there is a negative in the exponent. Our C term is negative 1. Okay? And so if you need to go back in your notes and look and see what this means, you can. Pause this video, see if you can figure that out, because this is a very important piece. Okay? That C term, just like it did back with quadratics, back with all of our other parent functions, that C term represented a horizontal something. Okay? It represented a horizontal flip or a horizontal reflection. Okay? And if it's a horizontal reflection, okay, think about that. If I'm flipping something horizontally, then what axis am I flipping over? If I'm flipping something horizontally from left to right, then I'm horizontally flipping over the y axis. So look over here on this graph. Say I've got this triangle here with these points. And I'm going to flip that over. I'm going to flip it horizontally over the y-axis. So I'm going to flip it to somewhere over in this area. Let's see. What changed? Did the x values change or did the y values change when I flipped this? Okay. The x values are what changed. Okay. Anytime we have a horizontal transformation, we are changing the x values. We're either adding or subtracting or multiplying or dividing those x values. Okay. So in this case, since c is -1, that means that all of our x values in our table of values, our x and y value coordinates, our x values are going to get multiplied by that -1. Okay? So hold on to that. We're going to have to use that when we start writing out our coordinate points. Okay? Is there an h, meaning is there an x minus a number or an x plus a number? Nope. And there is no k term attached at the back or in the front, like a 4 to the negative x plus 10 or 10 plus 4 to the negative x. We don't have a situation like that, so we don't have a k term to deal with. So the only thing that we have to work with right now is the base is 4 and the c term is -1, meaning our x values are going to get multiplied by -1. Pause this video and write out the basic big 3 points. Okay. So there are your basic big 3 points. 0, 1, 1, the base, which is 4, -1, 1 over the base, or 1 over 4. That is just filling in those big 3 values. However, we cannot forget about our transformations. So this is when we're starting to get a little more complicated here. Our x values must be multiplied by -1. So all of these x values over here, we got to multiply them by -1. Why? Because the transformation rule tells us we have to. Okay. So pause this video and multiply each of those x values by -1. Okay. These are the points that you should have. Okay. And so now, pause the video again, and I want you to go graph them, and then I want you to fill in the domain and range, the limits, and the asymptote. Okay. So you'll find your graph over to the side. Okay. I didn't ask you to identify this, but we can talk through it together. Is this graph an exponential growth or exponential decay? It is constantly decreasing, so this is an exponential decay graph. Okay. You'll see your domain and range. You'll see your asymptote listed up there. The one thing that I didn't fill in yet was the end behavior, the limits. As my x values approach -infinity, what are my y values doing? They are approaching infinity. Okay. As my x values approach positive infinity, to the right, what is the y value, or what are the y values approaching this time? They're approaching 0 this time. And the reason why that's happening is because that horizontal flip has made this a decay, which means what our graph is approaching is different. Okay? And so every single function, you're going to have to evaluate what are the limits doing based on what I see in the graph. Okay? Pause the video, write down some questions if you need to. Otherwise, we are going to move on. Here is your third example. Okay, f of x equals 4 times e to the x. Okay. First thing I want you to do, let's go off to the side and let's write out what's our base, what's the a term, what's the c term, what's the h term, what's the k term if we have any of them. Pause the video, write those out. Okay. Your base, what is being raised to the power, is e, which is, remember, we're going to treat that as 2.7 and only 2.7. And then that number in front of it, that 4, is acting as your a term. Okay, so go back to your transformation rules and look and see, what does a do? How does it affect your graph? Your a term is also dealing, or your a term is dealing with vertical changes. Okay, so if that was a negative, it would flip the graph vertically. Since it's a 4, it is vertically stretching the graph. And as you recall, vertical stretching, vertical is dealing with y values. So when we start looking at our big 3 coordinate points, we are going to be changing all of the y values by 4. And now keep in mind, this is not add 4 minus 4. This is take every y value and multiply it by 4. Okay, so pause this video, write out your big 3 points based on your base, and then adapt your y values by multiplying them by 4. Okay. Here are your big 3 points, just plugging in the base value, which is e, or 2.7. Okay. So we've got 0, 1, 1, 2.7, and then negative 1, 1 over 2.7. Remember earlier I told you this is just a number that you're going to have to memorize. Okay. I would go ahead and learn and memorize that 1 divided by 2.7 is 0.4. Just add it to your list of things that you need to learn for this chapter. Okay. But now, now I need to take all my y values, or f of x values, and I got to multiply all of them by 4. So each of these y values gets multiplied by 4. And you need to do that by hand, technically, since it's without a calculator. I can't stop you from using a calculator, though. So pause this video, come up with your points. Once you multiply by 4, you will have your complete set of points. Go graph it and finish out the problem. Pause video now. Check your answers. This would be your finalized response. Now, what I want you to think about is think about the structure from your last test. I had to break all of these things into individual parts. And so it's going to be very important that you write down everything on your notebook paper. A lot of you did not send that to me on time, and I told you if it wasn't sent on time, I have no way of knowing if it was done with integrity, or if there was cheating, or if it was forgotten and not done and then you went and did it later. You've got to get that stuff to me on time. I'm sorry if you were upset by that, but we got to have some professional behaviors in getting those things turned in and doing it based on the directions that were set ahead of time. I'm setting those directions for you right now from early on. Yet again, you need to be writing everything down on your notebook paper, because one question on your test may involve this function, just graphing it, and then 3 questions later I may ask you about the domain. Well, if you don't have it on your notebook paper, then you're going to have to redo this problem every single time to get one little piece of information. Or you can have it written down in your notebook paper and you can refer to it each time it comes back up. Okay? I think we've got maybe one more or 2 more examples. We're going to walk through those, and then we will be finished with part 1 of our lesson before we move on to graphing logarithms. Here is a function, an exponential function that I'm asking you to graph, but it looks a little different. It's f of x equals 1/3 raised to the x plus 1. Before you go any further, write out your base. Is there an a term, a c term, an h term, or a k term? Pause the video, write those out. What do you think? Okay. What you should have come up with, whatever number is being raised to the power is your base. And so in this case, 1/3 is your base. Okay. And so everything in our big 3 table of values points, your base is going to be 1/3. Now the only other thing that we have in this problem is an h term, which is positive 1. I want you to remember that when we talked about transformations at the very beginning, the h term was a little funky. There's a lot of different ways that you can think about it, but what we decided, the easiest thing for us to remember is that it's backwards. Okay? So if we are given x plus 1, then that means it's backwards. We're going to have a horizontal shift left 1, or we will be moving in the negative zone 1, or every x value will be subtracted by 1. That is what we've got to do to our coordinate values in our chart. Okay? Pause this video, write out your big 3 coordinate points, use your base of 1/3, and then every x value you need to subtract 1. Pause the video now, see what you can come up with. Okay? So when we write out our big 3 points, we'll end up with 0, 1, 1, the base, which is 1/3, and then -1, 1 divided by your base. Okay? So those fraction rules here, fraction within a fraction, you keep the top one, you change division to multiplication, and then you take the reciprocal or flip the second one. So 1 divided by 1/3 is the same thing as 1 times 3/1, which is where we get the number 3. Okay? And so there's our big 3 points, but we've got to make sure that we account for all of the transformations. We have an h term up here, and that h term says every x value I've got to subtract 1 from. Okay? So 0 minus 1 is -1. 1 minus 1 is 0. And -1 minus 1 is -2. There are your big 3 points. Those would be the coordinate points that I'm looking for you to have listed on your test or graphed. Okay? Pause the video, graph this function, and then fill in your key information about your graph. Check your answers. You'll see your graph in green. This is an exponential decay function because it is constantly decreasing. We still haven't had a vertical shift yet, and so our graph's not moving up and down at all, so the asymptote will remain at y equals 0. Okay. Your domain and range, we should be familiar with those numbers. They can still change, okay, but we need to be familiar with them. And then your end behavior and your limits. Okay. Let's take a look at our last exponential function for today's class before we transition to the second half of this lesson. Our last exponential function that we will take a look at is kind of a mouthful. It's got a lot going on. Okay. F of x equals -2 to the x plus 1 power minus 2. I want to see what you can do on your own for this one. So I want you to pause this video and I want you to start from the very beginning listing out what's my base. Is there an A term, a C term, an H, a K? What are my coordinate, my big 3 points based on that, and then graphing it. Okay? So pause this video, see what you come up with. I acknowledge that there's a lot going on with this problem, but if you can get through this one, then you are looking at one of the most complicated problems that I could give you. So if by the end of this you're understanding how to do it, or maybe you were able to do this on your own without my help, then you should be feeling very confident about content. You just need to make sure that you study consistently all these little details that we have covered in today's class. However, some of us may not be there yet, and that's totally fine. Again, there's a lot going on. We have a base of 2. Our A term is a -1, which means it is a vertical change. Specifically, it is a vertical flip, meaning all of my y values have got to be changed. They've got to be multiplied by -1. I have an h term, which is +1. Remember, that's backwards. That's a horizontal shift left 1, which means all of my x values have to move left 1, or x values have to be subtracted by 1. But then I also finally have a k term of -2. My k term tells me if my graph moves up or down. Since it is negative, it is moving down 2, which means my y values, all 3 of my y values, need to go down 2 or be subtracted by 2. So here's the issue. You have 2 different transformations involving y values. How do you know which one you do first? Okay. Q PEMDAS, or your order of operations. You do your parentheses and your exponents first. We're not dealing with that right now because we're dealing with an exponential function. The very next thing is take care of your multiplication first. Okay. So up here in your transformation rules, are you going to multiply your y values by -1 first, or are you going to subtract them by 2? Based on your order of operations, you are going to multiply by -1 first. Then you will subtract that by 2 second. Okay. So I just wanted to help you out with that. You can go ahead and pause the video again if that was helpful for you to keep going, and we'll reconvene in just a few moments. Just doing a little check-in. Check to see that you got your 3 big points correct before you go any further. And once you do, go ahead and graph them. If you didn't get these, try it again. If not, write down your questions and contact me. Alright, so you should see your graph right here in green. You'll notice that I haven't filled in all of my things yet because I want to walk through those step by step with you. Hopefully you have done that so that you can either check your answers off as correct, or we can adapt them and change them and learn from them. Okay. So based on our graph, based on our transformation rules, our domain is still -infinity to +infinity. X values are going to keep going forever and ever. Now the range is where it starts to get a little tricky. Remember, the range is a set of y values. Up until this point, our range has always been the horizontal asymptote up to infinity, or -infinity up to the asymptote. So we need to address what the asymptote is, we need to address what the range is, so on and so forth. Are any of our transformations changing the horizontal asymptote? Remember, the horizontal asymptote is y equals 0. Did any of our transformations shift that? Okay, that would be a vertical shift. Okay. Did we have a vertical shift or a k term? The answer is yes. Okay, we had a k term of -2, which means our graph shifted down 2. So our horizontal asymptote is not y equals 0 for this problem. Our horizontal asymptote is y equals -2, which is right there on this dotted line. Okay, you got to get that. Okay, and again, that shouldn't be too much of a complicated thing because it's a review from previous chapters. Okay, the only thing new are these big 3 points and graphing them. Everything else is old news. If you haven't learned that, then you're going to need to really study up. Okay, but if our horizontal asymptote is y equals -2, then that means the range is also impacted. The range is a set of y values. In this case, it's going to be -infinity up to the y value of -2, because the graph doesn't ever go past -2 in terms of y values. Okay. Same thing with our end behavior. As my x values approach -infinity, what is the graph? What is the y value graph approaching? It's approaching y values of -2. The limit as my x values approach +infinity, what is the graph approaching? -infinity. infinity. Look at that. The graph is going down forever and ever. So the y values are approaching negative infinity. Those are all the exponential function graph examples that I have for you. I've given you a little bit of each kind, so that should be the best prep that I can give you in terms of prepping for your homework, prepping for our upcoming test, all the above. Okay, so make sure you take a look at your homework and maybe try that. I would always suggest picking the homework of the content that you struggle with the most, because that's the one that you need the most practice on. Okay. Stay tuned. You've got a part 2 video for today's class, and I will attach it into the YouTube channel, Google Classroom, and on Wolf Den. So make sure that you're paying attention to that, and make sure that you actually get to that lesson for today's class as well.